Okay, today we're going to be talking about using elimination on a system of equations that have 3 variables and 3 equations. Okay, and this is using like the addition and subtraction, the easiest of the methods we're going to talk about, and slowly work our way to difficult ones. So, okay, first thing to keep in mind when you're dealing with these, make sure you write down this system, pause the video, and write it down so we can walk through it together. And the second thing, our main goal is to go from 3 equations with 3 variables, x, y, z, a, b, c, whatever it is, down to 2 equations with 2 variables, and then down to 1 equation with 1 variable. And then you can use like your elimination substitution method when you get down to 2 and 2, but we had to get there first. So that's a huge goal we want to make sure we have down in our notes. So we first need to decide which variable that we're going to eliminate. Well, if you look at the x terms, you have 5, 5, and negative 5. We can find a combination that we can add those together to eliminate them. If you look at the y's, 4, 4, that's good. 3, not so good. And the z's, the 2's are good. The 4 is not the same. So it looks like x is our best option here. So we're going to start off by saying we're going to eliminate x. Okay? Okay, now I'm going to actually label these 1, 2, and 3. So when I reference them throughout the video, you'll know what I'm talking about. Okay, to first get rid, remember I need 2 equations with 2 variables. So my first equation without x, because remember I'm eliminating x. Well, if you look, we have a positive 5x here and a negative 5x here. So I can add 1 and 2. Because when I add those together, my x's are going to cancel out. So 5x plus a negative 5x gives me 0x plus 4y plus a negative 4y. Well, it's a 0y. Got lucky there. 4z plus 2z is 6z. I don't know why I made the z so big, whatever. 24 plus 6. Don't forget, a lot of students forget to add the answers as well. You have to add each part of it. So this is after I've added 1 and 2. Now we can make it look nicer. 6z equals 30, and z is just going to equal 5. So we could go back and we could substitute 5 in for z and change those up. Okay, that's fine. I'm suggesting we do this just to get a little bit more practice. So let's just say, it's not always going to be nice and easy like this, but let's say z, we didn't find out what z was, we still have y. Now we need to get a second equation without x. Okay, so our second equation without x, well, if I look, I have a positive 5x, negative 5x, positive 5x. So I need opposites of the same coefficient. So I have a negative 5x and a positive 5x. So I'm going to add 2 and 3. So adding 2 and 3, negative 5x plus 5x gives me 0x. Negative 4y plus a negative 3y minus 7y. 2z plus 2z, negative 2z, 0z. 6 plus a negative 13 is negative 7. Making that look nicer. Negative 7y equals negative 7, and y is going to equal 1. Okay, now that I know what y and z are, I can use those to find x. And the nice thing about a system is we can pick any of these to substitute these values in for to find x. I'm just going to pick number 1. So we're going to substitute y equals 1. This equals 5. In the beginning when you're doing these problems, it's nice to write them out, these steps, so you understand what you're doing when you go back to look at them later. And remember, it doesn't matter which one you pick. Put a note there. It doesn't matter. You could have done 2 or 3. I just picked 1. No big deal. So you get 5x plus 4 times 1. That's y. Plus 4 times 5. That's z. I just substituted into this. Equals 24. Making that look nicer. 5x plus 4 plus 20 equals 24. This is 24. I'm going to subtract it to the other side. 5x equals 0. So x equals 0. Then finally what I can do, I can write these as an ordered triple. And we just go order of the alphabet. So it goes x, y, z, 0, 1, 5. So this ordered pair tells me that this is the, or not ordered pair, ordered triple, excuse me. This is the only ordered triple that works for all 3 of these at the same time. Okay, so we're kind of like the 3 planes intersect. But it's the only one that works. Okay. Okay. Let's try a second one here. Okay. Okay, so be sure again to write this down. If you want to even take a second to try to figure this out, pause the video, and then come back and see how you did. Okay, so remember our goal is to go from 3 equations with 3 variables down to 2 equations with 2 variables, and then eventually down to 1 with 1. So we've got to pick a variable to eliminate. Well, look at this. Yet again, x, all our lead coefficients are the same, and 1's negative. That's perfect. It doesn't always have to be x. Just in our cases, it turned out to be. Y, these are the same, but a 3, kind of ugly. Z's, these are the same, but 2. So x is our best choice. And remember, I'll say it again, it doesn't always have to be x. Okay, so I need 2 equations that don't have x in it. So the first, so my first equation without x, well, if I were to add 1 and 2, I see negative 4x, positive 4x. They cancel out. Oh, I guess I should label them too. So add 1 and 2. Okay, negative 4x plus positive 4x is 0x. Negative y plus a negative y is negative 2y. Careful there. Z plus a negative 2z is minus z. 16 plus a negative 16 is 0. And you can make this note look nicer. Negative 2y minus z equals 0. So here's an equation that doesn't have x in it, just y and z. Okay, now I'm going to find my second equation. So my second equation without x, well, if I were to add 1 and 3, the 4x's kind of cancel each other out. So I'm going to add 1 and 3. Doing that, negative 4x plus 4x gives me 0x. Negative y plus 3y is plus 2y. Z plus z is 2z. And 16 plus a negative 16, oh, that is also 0. So 2y plus 2z equals 0. Okay, so now I have two equations that don't have x in it. So I'm just going to make this look nicer. I'm going to bring this guy. So 2y plus 2z equals 0. Now look at this. We have a system of equations with two variables and two equations. So now I can do what I've learned to eliminate one of them. Well, if you look at the y's, they both have a 2 and a negative 2. So if I just add these together, negative 2y plus 2y gives me 0y. Negative z plus 2z is 1z. That equals 0. So z equals 0. Okay. Okay. Then once we know z equals 0, we can use that to substitute it in to find y. So now I'm going to have 2y. Remember, you could use either of these. I'm just going to use the pink. Doesn't matter. Plus 2. And instead of z now, I'm going to put 0. That's what I just found. Okay? And that equals 0. So that's 0 right there. 2y equals 0. So y also equals 0. That's always cool. Okay, then we can find x. And just like before, we can take our y and our z and substitute it into any of these to find x. Last time we did the first one, let's do the second one this time. So now I get 4x minus 0. Remember, I just substituted the first, or to the second. Minus 2 times 0 equals negative 16. 4x, this is 0, that's 0, so equals negative 16. X equals negative 4. So then I write my answer as an ordered triple. X was first, negative 4. Y was 0. Z was 0. So Mr. Pons, what does that mean? Great question. This is the only ordered triple that works for all three of these. Spend the rest of your life trying to figure out another one, and you won't. This is the only one that works for all three of them. Okay, so that's the elimination using some addition there. It does get a little bit more difficult, but having this idea, going from 3 equations to 3 variables, down to 2 equations with 2 variables, then eventually down to 1 with 1 variable, is the key for it. Okay?